Alright, so you had a take-home problem. Let's do this take-home problem together. Now, before you do the take-home problem, remember we talked about last time, we said that we need to learn how to convert between gram, moles, and molecules and atoms. And the chart that I put up, which I like this chart, and make sure you have it in front of you as you're doing practice problem, is that you can go back and forth between grams to moles, and then you can go back and forth from moles to atoms, molecules, and ions, depending on what you have, right? We talked about that you have an ion, you have a molecule, you have a atom. So to go from grams to moles, you need molecular weight. To go from moles to atoms, molecule, and ions, you need Avogadro's number. Okay, now let's do this problem. So, and I like this problem because I didn't tell you the formula to see if you remember our naming. Gold 3 nitrate. Gold 3 nitrate. Okay, what is the formula for gold 3 nitrate? It would be AuNO3 3. You guys got this down? Because I'm telling you it's gold 3, so gold has a +3 charge and nitrate has a minus charge. So when you cross multiply the charges, this is what you get. It's a little good practice from last time what we talked about. So I'm going to write down what's given to you. You should always write down what's given to you. 6.60 times 10 to the 21st molecules of AuNO3 3. Are we good so far? Okay, so this is what's given to me. Where am I? I am right here, but what I want to get to is over here. So I'm right here, I have molecules. What I want to get to is right here, grams. Can I jump? Hopefully you're telling me no, you can't jump. The only way to do this is go from here to here and from here to here. I go to molecules to moles and then moles to grams. We're good so far? Okay. Now, the first thing again, canceling out is your best friend. We said we don't want molecules and what we're trying to get to is moles. So molecules come down here and what's going to go on top is mole. How do I go from molecules to moles? Avogadro's number. And we said that Avogadro's number is always for 1 mole. Avogadro's number is always for 1 mole. So 1 mole is going to be 6.02 times 10 to the 23rd molecules. You following me so far? So then the molecules can cancel out. So Avogadro's number is always for 1 mole. 1 mole is that many molecules. The same thing, 1 dozen is 12x. Okay. So the molecules cancel out. I have moles. Now I need to go from moles to gram. I know that. This is easy. I need to cancel out moles. It's going to go down here. What I want on top is grams. Okay. So then the moles can cancel out. And I can end up with grams. How do I go from moles to grams? Molecular weight. Molecular weight. Okay. So what you had to do, you had to add up gold molar mass plus how many nitrogen? 3 nitrogen molar mass and 9 oxygen molar mass to figure out the molecular weight of this. So let me write this down just because to make sure that everyone's on the same page. So to convert from moles to grams, I need the molecular weight of gold 3 nitrate. How do I figure out? For molecular weight, I have 1 gold, I have 3 nitrogen, and I have 9 oxygen, and I have 9 oxygen, right? Where does the 9 come from? You have to multiply this out. I have 3 nitrate. If I have 3 nitrate, that means I have 3 nitrogen and I have 9 oxygen. So what you would have to do, you would have to add up all these numbers, right? Look at the periodic table, grab their molar masses and add them up. if you do that, what you end up getting is 383 grams per mole. Okay, again, you get those numbers from the periodic table. You figure out the molar mass of gold plus molar mass of nitrogen times 3 plus molar mass of oxygen times 9. You add them up together, you get 383. Okay, so then, and we said that molar mass, molecular weight, is always for 1 mole. So 1 mole of gold 3 nitrate is going to be 383. Okay, so molecular weight is always for 1 mole. Avogadro's number is always for 1 mole. Don't forget that. So everything gets cancelled out. I end up with grams. Now, how many sig fig do I want? How many sig fig do I want? What do you guys think? How many sig fig is this guy over here? This is 3 sig fig. So this is 3 sig fig. Okay. Now, this one doesn't matter for sig fig, and this one doesn't matter for sig fig, because sig fig is something that you measure. And what has been measured is this number over here. These are just almost like a conversion, right? These are a conversion. We just get this number from the periodic table. We get this number, that's like our conversion factor. So this is the final answer should have 3 sig fig. Now, with a 3 sig fig, ends up being 4.20 gram. Okay, hopefully you guys got this down. All right, nice job. This was a hard one. Again, the take-home problems are hard. Hopefully you get it down. Again, the key is look in here where you are, where you're trying to get to. You can't jump. You have to go step by step and try to cancel out. Molecules go down here so they can cancel out. Moles goes on top. Now moles goes down here. They can cancel out. Grams on top. And then look at the relationship between those two. Nice job. Ready for next one? Okay, we're going to keep doing practice problem. We're going to get a little bit harder, but once you have the basics down, there is no problem you won't be able to do. How many moles of Br are in 20.0 grams of FeBr3? Highly recommend you to pause me, do this problem, unpause me, and then check your answer with me. This one is a little tricky. So, but always write down what's given to me. What's given to me is 20.0 grams of FeBr3. I want to go from gram to moles. Okay? You know how to go from gram to moles. I'm going to come back over here. How do you go from gram to moles? You use molecular weight. I have grams. I want to go to moles. I use molecular weight. Okay? That's not bad. Now, grams go down here, moles gonna go on top, right? And we'll have to figure out the molecular weight of FeBr3. Now, if you do that, you're gonna say that 1 mole of FeBr3 is 295.5 grams. You don't need to, because it's 5, you don't really need to round it. I wouldn't round it right now because it's 5 and we don't want the final answer to be too off. So it's okay if you leave it as those 4 significant figure. So far so good? Okay. So then the grams can cancel out. Perfect. I have moles. Easy, huh? A little too easy. Now, here's the problem. I didn't ask you to get me moles of iron 3 bromide. What did I ask you for? I asked you for moles of Br. This is really key in chemistry. I need you to pay close attention to me. So I gave you the grams of FeBr3, but I asked you for the moles of Br and not moles of FeBr3. Is everyone on the same page as me? So, this is huge deal in chemistry. You're going to see this so many times. What happens is, I give you A, but I ask for B. I give you FeBr3, but I ask for Br. So I give you one thing, but I ask for something else. every time this happens, every time that I give you one thing, but I ask for something else, what you need to use is, this is really key in chemistry, I'm even going to give it a hashtag that because it matters. Hashtag mole ratio. You got to use the hashtag for me because it's more fun. Hashtag mole ratio. So every time I give you one thing, but I ask for something else, what you have to use, you have to do hashtag mole ratio. Now, let's do this hashtag mole ratio right now. So, what is this mole ratio? I don't want the moles of FeBr3. So, I'm going to write down the moles of FeBr3 down here. What do I want? I want the moles of Br. Okay? I don't want the moles of FeBr3. I want the moles of FeBr. Now, what is the mole ratio? Here's the thing. In one FeBr3, how many Br do you have? You have 3 Br. In one FeBr3, in one compound here, you have 3 Br atoms, right? So, what the mole ratio is going to be, the mole ratio is going to be, in 1 mole of FeBr3, I have 3 moles of Br. And now this is great because the moles of FeBr3 cancel out, and I end up with moles of Br, which is what I want. I know this was crazy, but this is the last thing to learn about this chapter, and it comes so handy. You really gotta know this. You really gotta know this. So far so good? Okay. And the same as before, we're gonna multiply everything on top, divide by the bottom. If you do that, what we end up getting, how many sig fig? How many sig fig? Tell me, how many sig fig? This doesn't count in sig fig. This doesn't count in sig fig. This has 3 sig fig, right? This has 3 sig fig. So my final answer is going to have 3 sig fig. Again, this doesn't matter. It's almost like an exact number. This is exact number. This one doesn't affect the sig fig because it's more like a conversion, right? You didn't measure it, so doesn't matter. And my final answer is gonna have 3 sig fig. So my final answer is 0.230 moles of Br. This was a crazy one. But this is gonna come back over and over again. So make sure you guys are getting this down. So far so good? Alright, ready for next practice problem? Hashtag mole ratio. That's our key. That's the key today. Here's the next problem. Okay? And I already wrote this down too because you have to have this in front of you every time you're doing practice problem. Alright, pause me, do this, and then unpause me, and then let's go over this. So, what is given to you, and always write down what's given to you. You have really no choice, but you should write down what's given to you, is 10.0 grams of MgCl2. Okay? What I want to go to moles. I have gram, I want to go to moles. Okay? To have gram, to go to moles, it goes over here. I need to use the molecular weight. Okay, that's great. So, I don't want gram, it goes bottom. What I want is mole. Hopefully you guys getting this down so that your gram can cancel out. I have mole. How do I go from gram to mole? Using the molecular weight. Molecular weight is always for 1 mole. Molecular weight is always for 1 mole. 1 mole of AgCl2 is 95.2 grams. Hopefully you guys are getting down these molecular weights, right? You just add up Mg and 2Cl. I get 95.2 grams. That's 1 mole of MgCl2. Okay? So 1 mole of MgCl2 is 95.2 grams. So the grams cancel out. What I have now, I have moles. But if you look at this question, they give you the grams of MgCl2, but they ask you for moles of Cl. Okay, they give you one thing, but they ask for something else. This will be happening a lot in chemistry. They give you one thing, but they ask for something else. But you know how to do that. What do? If they give you one thing, but they ask for something else, you have to use hashtag mole ratio, right? Again, mole ratio is like they give you one thing, they want something else. They give you the grams of MgCl2, but they want the moles of Cl. So I went grams to moles, but now I have to do a mole ratio to convert to what I want, because I don't want the moles of MgCl2. What I want is the mole of Cl. Okay, again, I don't want the moles of MgCl2. It's going to go down here. Why is it going to go down here? So I can cancel it out. To cancel out, they have to be on their opposite side, right? So now I can cancel the moles of MgCl2 and get what I want, which is moles of Cl. They give you one thing, you want something else. You have to use hashtag mole ratio. Now, what is our mole ratio here? What is our mole ratio here? In 1 MgCl2, how many Cl do you have? You have 2 Cl. So for 1 mole of MgCl2, I have 2 moles of Cl. I have 2 moles of Cl. Okay, so if you multiply everything out, okay, now again, I know you know this, but just in case, 10.0 times 1 times 2 divided by 95.2 divided by 1. Now, my final answer has how many sig fig? Shout the answer for me, even though I can hear you. This is 3 sig fig, right? 3 sig fig, exact number doesn't matter, exact number doesn't matter. This is almost like a conversion. Counting doesn't matter. 3 sig fig is my final answer. So my final answer should be 0.210 moles of... what am I doing? Moles of Cl. Sounds good? Okay. Nice job, nice job. Alright, we're going to keep doing practice problems. We're going to keep doing it until you get this down. Okay, here's our next one. Pause me, do this, and then we're going to go over it together. If you can do this one, then I feel really, really good about this chapter and you knowing this chapter. You are given 145 grams of glucose, which is C12H12O6. We talked about this before. Every time you're going to put sugar in your coffee, you're going to be thinking about, oh, this is C6H12O6. I know what this is, which is kind of cool. So I'm going to write down what's given to me, which is 145 grams of C6H12O6, okay? Now, what they ask you is how many molecules you have. So they give you grams of glucose. They ask you how many molecules of glucose you have. Now, this is, you know how to do this. They give you grams, they want molecules. They give you gram, they ask for molecules. So we have to go gram to moles and moles to molecules. Gram to moles, moles to molecules. Gram to moles using molecular weight, moles to molecules using Avogadro's number. Okay? So, I have grams of glucose. I have to convert it to moles first, right? So if I want to convert it to moles, gram goes down here, moles goes on top. Very good so far. How do you go from gram to moles? Using molecular weight. Using molecular weight. And molecular weight is always for 1 mole. So 1 mole of C6H12O6 is 180 grams. Okay? Again, what I use here, this is a molecular weight of this. 6 times 12 plus 12 hydrogen plus 6 times 16. You add up all the molar masses, you get 180 grams. So the grams can cancel out. And I have moles. And I have moles. But now I don't want moles. What do I need to go? What I need to go is moles to molecules. I have to go moles to molecules. Now I'm going to write down moles here. And I'm going to write down the molecules on top. Okay, how do I go from moles to molecules? Again, now moles can cancel out. I can end up with the molecules that I want. To go from moles to molecules, I need to use Avogadro's number, right? And Avogadro's number is always for 1 mole. 1 mole of glucose would be 6.02 times 10 to the 23rd molecules. I know I'm repeating myself so much. Let me repeat myself one more time. Remember, Avogadro's number is always for 1 mole. Molecular weight is always for 1 mole. That's our standard. Everything is for 1 mole. Alright, so everything cancels out. Alright, so now you have to multiply everything by top divided by the bottom. My answer should have how many sig fig? Tell me. The final answer should have 3 sig fig. Why should I have 3 sig fig? Because this guy over here has 3 sig fig. This one doesn't matter for sig fig. Doesn't matter. Those are all conversion. Okay, so my final answer with 3 sig fig would be 4.85 times 10 to the 23rd molecules of glucose of C6H12O6. Yeah? Okay. Good job. I know we've done this before, but sometimes repeating a question really helps. Now, next part is, read next part for me. If you read the next part, it says how many atoms of O are in 145 grams of glucose. Now, before we do this, what type of problem is this? What do you have to use eventually in this problem? They give you glucose, which is 145 grams of C6H12O6, but they ask you for atoms of O. So what do you have to use? Hashtag mole ratio. We have to use mole ratio because they give you one thing, they ask for something else. Okay? Now, let's do this again. And again, we can do this from the beginning. So what I have, again, I have grams. And what I want to go from grams to atoms. But I have to use a mole ratio as well to be able to get to what I want. Again, I have grams going to atoms. That part hasn't changed. I have grams going to atoms. I do grams to moles, moles to atoms. But I also have to do a mole ratio because I have one thing and I'm trying to get to something else. So, I'm going to write down what's given to me, which is 145 grams of C6H12O6. Okay? The first thing I need to do, I need to convert it to moles, right? I need to convert it to moles. Now, 1 mole of C6H12O6 is 180 grams. So 1 mole of that is 180 grams. I know that from the last problem. Okay, so this is great. The grams can cancel out. Okay, so I went from grams to moles. But before I go to moles to atoms, this is the easiest way. There's different ways you can do this. Is now I have to do a mole ratio, right? So I went from gram to moles. But then, now I need to do a mole ratio. And again, why do I need to do a mole ratio? Because what's given to you is C6H12O6. What they want is just the oxygen. What given to you is C6H12O6. What they want is just an oxygen. They give you one thing, they want something else. Mole ratio is what we have to use. So I'm going to convert grams to moles, which you know how to do. And now I'm actually going to do a mole ratio. Now that I have moles, I'm going to do a mole ratio. Okay? Now, what I don't want is moles of C6H12O6. What I want is moles of just oxygen. Okay? Again, I want to do a mole ratio here because I don't want C6H12O6. I want oxygen. And I like to do the mole ratio when I get to moles, right? So this moles can get canceled out. I can end up with moles of O2, which is what I want. Now, what is the mole ratio? In one C6H12O6, how many oxygen you have? You have 6 oxygen, right? In one of these, I have 6 oxygen. Okay, so now I have moles of oxygen, which is what I want, which is great. So when you get to moles, do the mole ratio. Now, they don't ask you for moles of oxygen. They ask you for atoms. How do I go moles to atoms? Avogadro's number. That part hasn't changed. So for moles of oxygen, but I want to go to atoms. Now, you already know how to do that. 1 mole is 6.02 times 10 to the 23rd atoms. So that process hasn't changed. What we did, we went from gram to moles using molecular weight and from moles to atoms using Avogadro's number. This part didn't change. The only thing we had to add in between is using a mole ratio. After you convert to use a mole ratio. Mole ratio, that's the key today. To get to where I want, and then I convert it to atoms. Again, there are different ways to do this. You can convert this later, but I like to convert it here as a mole ratio. Okay, now, my final answer has how many sig fig? You already know this, because this guy over here has 3 sig fig. The rest, these don't matter in sig fig. So my final answer has 3 sig fig. It would be 2.91 times 10 to the 24th atoms of O. So the whole process was exactly the same as we've done before. The only thing I've added was a mole ratio. The only thing that we've added was the mole ratio. Oh, this was a big problem, yeah? You guys ready to do more practice problem on this? Let's do this. Here's our next problem. Okay. How many grams of C are in 2.15 times 10 to the 24th molecules of aspirin? The same thing as before. The first thing that I'm actually going to do right now, I'm going to write down our chart because everything comes back to this chart. Grams goes back and forth to moles, and moles goes back and forth to atoms, molecules or ions, and this one is the molecular weight. This one is Avogadro's number. Okay? All right. Now, we have to write down what's given to us. And what's given to us is 2.15 times 10 to the 24 molecules of C9H8O4. Okay? This is what's given to us. Now, here's how we are going to approach this problem. You ready? What's given to you is molecules of C9H8O4. So this is what's given to you. But what did I ask you for? Just carbon. So what's given is C9H8O4. So I'm going to write this given actually over here. What you want is just carbon. Okay? What's given to you is the molecules of C9H8O4. What they want is carbon. If they give you one thing, but they want something else, what do you have to use? You have to use mole ratio. Okay? So I'm hoping now you're recognizing that type of problem. Again, they give you C9H8O4, but they ask you for carbon. So far, so good. So now you know that you have to do mole ratio. Okay. Now, beside that, what we have molecules over here, and we're trying to go to grams. So we have to go molecules to moles, do a mole ratio, and moles to grams. Our basic for before hasn't changed. You have molecules, you're going to go molecules to moles, and now we're just going to do a mole ratio because we've given one thing, we want something else, and then go from moles to grams. All right, you following me so far? Okay. So the first thing that we need to do, we need to convert molecules to moles, right? And you know how to do that, right? 1 mole of C9H8O4 is 6.02 times 10 to the 23rd molecules. So the first thing that we did, we went from molecules to moles. We know how to go from molecules to moles. We use Avogadro's number. Avogadro's number is always for 1 mole. Okay? Now that we're here, now that we're at mole, let's do the mole ratio to get to what we want. What we want is not the moles of C9H8O4. What we want is moles of what? Just oxygen. Okay, so again, I went from molecules to moles. Now that I'm at moles, let's do hashtag mole ratio. Okay, so now I'm going to do my mole ratio. I don't want this one. I don't want C9H8O4. What I want is oxygen. So I'm going to do a mole ratio to cancel this one out. What's the mole ratio over here? Help me out. What's the mole ratio? In 1 C9H8O4, how many oxygen you have? Sorry, it's, carbon. What am I doing? What we want is carbon. I did not just do this, guys. Sorry, we wanted carbon. Okay. What we wanted was moles of carbon. So in 1 C9H8O4, how many carbon do you have? You have 9 carbon. In 1 mole of C9H8O4, you have 9 moles of carbon. I made that mistake, so to make sure you're paying attention. We're good now? Okay. So we cancel out the C9H8O4 and we end up with what we want, which is carbon. All right. Now, are we done? We're not done yet. I asked you for grams. We did the mole ratio. Now we're going to go from moles to grams. Now we're going to go from moles to grams. Now, how do you go from moles to grams? You know how to do that. To go from moles to grams, you need molecular weight. 1 mole of carbon is 12.0 grams. So, now I can calculate my final answer. Because if moles of carbon cancel out, I end up with grams of carbon. Before you tell me what your final answer is, this is a really hard question. This is a big question. If you can get this, you're in a really, really good shape. Let's go back one more time. They give you C9H8O4. They want carbon. Every time that's the case, that they give you one thing, but they want something else, you have to use mole ratio. You have to use hashtag mole ratio. You have to use a ratio when they give you one thing, but they want something else. Now, we can use a mole ratio when we get to moles, but we also have to do the rest of the process. They give you molecules, they want grams. So we know we have to go from molecules to moles, from moles to gram. But once we go from molecules to moles, before we move on, let's do the mole ratio here, right? We have moles, let's do the mole ratio here. So that's what we did. We had molecules, we converted molecules to moles, we converted molecules to moles using Avogadro's number. The molecules cancel out, 1 mole, okay. Now that I have moles of C9H8O4, I'm going to do a mole conversion to get to what I want, because C9H8O4 is not what I want. I want a carbon, and the mole ratio is I have 9 carbon in 1 C9H8O4. So I do the mole ratio here. So now I have the moles of carbon, which is what I want, and then I have to go from moles to grams. Now I have to go from moles to grams, and I do that using the molecular weight of carbon. That part hasn't changed. Okay. This is a hard problem. But I'm giving you this hard problem now instead of giving it to you on exam, right? This is a better place to give you a hard problem. Now, my final answer should have how many sig fig? My final answer should have 3 sig fig, right? My final answer should have 3 sig fig because this has 3 sig fig. I'm going to multiply everything by top, divided by the bottom. Do not forget parentheses over here. Multiply everything on top, divide by the bottom. Don't forget parentheses. My final answer is 386 grams of carbon. Yeah? Okay. Now, this problem was so intense that I forgot to mention what's really cool about this problem. The cool thing about this problem is this problem was about aspirin. You all have probably taken aspirin at some point in your life. Probably if you're taking chemistry class right now, you're taking aspirin every day. after every lecture. Hopefully not. So now, if aspirin, next time you take an aspirin, you can go, oh, I know the formula for aspirin. It has 9 carbon, 8 hydrogen, and 4 oxygen. Isn't that crazy? That this is a drug that you use all the time, and you know the formula of it, and you understand the formula of it. So things seem less scary when you take a chemistry class, because you go, oh, all these things that I use that I had no idea what they're made of, now I know what they're made of. It's kind of cool, right? Just a little bit. Now, ready for a take-home problem? Here is our take-home problem. This is a hard take-home problem. You do this take-home problem and you get it right, we are in a really, really, really good shape. Okay? So please, please work on this take-home problem. That will be the first thing we do next time.